Thank you for joining today, everybody. Hope you're having a fantastic conference. I'm Michael, and I'm going to talk to you about JDK Flight Recorder. Hands up, who has heard about JDK Flight Recorder before? Keep your hands up if you've used Flight Recorder. Okay, that's a larger number of people than normal, I'm going to say. So that's nice to see. We're pretty proud and happy with JDK Flight Recorder, and I'm going to spend the next 40 or so minutes talking a bit about what JDK Flight Recorder is and how you can use it. And this is going to be demo heavy. I've over-rotated, if nothing else, on demos today. So let's see if the demo gods are with us. But let's start with what is JDK Flight Recorder for at least those of you who maybe haven't heard about it before and don't know what it is. So we started out 20-something years ago now, 25 years ago or so. I was working on a JVM, not the hotspot JVM that is in JDK today, but in a separate one, or a different one. But it shared many of the same challenges and opportunities. And in particular, what we noticed was our support and sustaining people were in the same office. And every once in a while, we met up at the coffee machine and we discussed what their biggest headaches that specific day was. And in general, the challenge for them was getting information out of the JVM. So they were seeing customers running into issues, or they were debugging something and they couldn't get the information out of the JVM, right? It was there. We knew that because we're doing all this work in the background, collecting things, using that to improve on how a job is being executed inside the JVM, but the information sort of got stuck, right? Well, there was no way of getting it out of there. So the idea came up to do something like they do in the aviation industry, right? There's the black box, or in this case, like as we all know, it's orange, right? Collect information constantly, and when you need it, it's there. So we package it up nicely and you can get to it later. So that's effectively what Flight Recorder is in a nutshell. I'm going to say probably JFR sometimes when I mean, or I still refer to JDK Flight Recorder. So just for information, JFR is the short version of it. It is an event-based recording framework, and I'll step through on the next few slides what exactly that means. But as you can imagine, it's event-based, so there's something called events, and we'll look at what that looks like. As I mentioned, it is designed to collect data continuously and do that all the time so that you have it when you need it. This data is aggregated in something we call recordings, JFR recordings. Those recordings can optionally be written to disk when you need them. So conceptually, this is all happening in the background in memory. There's a small asterisk, but I'll skip that. That's technical details. But if and when you need the data, you dump it out and you get a recording. And the nice part about this recording is that it's standalone. It has all the information in it so that you can do analysis offline. And we'll actually look at how you can analyze data in process at the same time as the recording is going as well a bit later. The other thing to know about Flight Recorder is that we have designed it to have extremely low overhead. And as a matter of fact, the design is such that you should have it on in production. We are running with this on in production. So the overhead is less than 1% in the default configuration. So basically, there's a small overhead, but you won't notice it. And that's true for the CPU. There's also a small memory overhead. It's configurable, but it's basically, again, for production. I want to stress that a few more times. I'll try to say it later as well. Many people look at this as a profiling tool that you only use during development, and that's powerful, the powerful use case, but I will argue that it's in production, digging into what went wrong. That's when this really shines, and it's, again, designed to be used in production. So to that end, we have both APIs for producing events. So there are events built into the JDK itself. I'll get back to what an event is and some of the events that we have in the JDK. But you can produce your own custom events and feed that data into the same recording so that you correlate it to what else is going on in the system. You can use the APIs allow you to control the recordings themselves and also to consume data and analyze it. And speaking of analysis, we have both command line tools, and I'll show you that in demos later. We also have a GUI called JDK Mission Control, and I'm not going to go through that in as much of detail, but at least I will show you quickly what that looks like as well. But then you can do your own custom code or custom agents to analyze this data as well. So we'll look at more about that later. So events and recordings are very central to how JDK Flight Recorder works. So let's start there. What is an event? So this is sort of an event in a nutshell. So an event has a type. It's representing something, right? Be that, in this case, a garbage collection, information about what that garbage collection did, or your custom event for, I'll show you a demo later of, your database query or whatever it is really, right? Could be any level, any kind of information. An event has an ID. It's just where it is in the stream, or to be able to identify it and refer to it. It has a timestamp, so when did the event happen? An event can have a duration. Not all events do. Some are instantaneous, but some events where you really want to start the clock and stop it at some other point can have a duration, so it's optional. Depending on which kind of event it is, there can be a thread associated with it. So in which thread was this code executing when the event got generated? It can have a stack trace, and I'll get back to that on the next slide here. Stack traces are, we think, a key value of JFR as well. So because obviously it's great to know that something happened, but in order to sort of troubleshoot it and figure out how, what happened to make that happen, it's nice to have the stack trace. And then finally, there is event-specific data on top of that. So like these are conceptual fields in an event that are common for all of them, but then depending on the event, you can have specific information on top of that. So we see an example on the right there, a garbage collection event. It, for example, has a sum of pauses field, right? So that's specific to that event. And it has a longest pause as well. So that's just an example of what an event can look like. We'll look more at events later as well. Here's another example of a custom event, which I'll show you how it actually got implemented a bit later during the session. And the key thing here I want to point out is that stack trace array that you see at the bottom. That is the stack trace that led up to the generation of the event. And one nice thing about JFR is that it's very efficient at capturing all this data and storing all this data. So stack traces are normally very costly to collect and store, but we have, being the JVM, we have figured out how to do that very efficiently. So you, again, should run this in production. That's the message, right? I'll say it a few more times later. I mentioned that we do generate events in the JDK itself. This is not an exhaustive list. It's just my favorite examples maybe of what's happening or what's included. It's everything from the environment you're running in. So which operating system and CPU are you running on? Can be useful for debugging and troubleshooting things later. It's the JDK version, which is of course of interest. The command line that got used to start up the application, that sort of thing. On the library side, we have everything from the execution itself. So what are the threads up to? So we sample threads or include thread dumps, if that's a more familiar term to you. We have information about file and socket I/O or network I/O. There's also a number of, and we're growing this list, by the way, constantly as we realize that there's other kinds of information that we want to include as well. But for example, on the security side, we're including things like the crypto protocols that are in use, which can be of interest, obviously, if your app is depending on something and you realize that that's a protocol you want to get off of, sort of, right? That's information we're capturing. TLS handshakes, what happens when you connect to a server, and the TLS handshake involved in that. And also certificates, right? Information about which certificates are being used so that you can go in and look at this application and see that, oh, yeah, that certificate is about to expire a month from now. I had no idea my application was using that, right? So those are examples. And on the JVM side, it's the expected stuff, I guess. It's things related to garbage collection, to JIT compilation, to class loading, exceptions, thread synchronization, sort of the works. So lots and lots and lots of information included. And again, less than 1% overhead for all of that. One of the reasons why that works out so well is that built into JFR, we have very powerful filtering and configuration. So in particular, what we do is we realize that not every event may be of interest, depending on certain factors. So for example, if you're trying to grab a lock and you immediately get that lock, right? You synchronize on an object and there's no wait time, it's not so relevant, right? It's probably not worth including that information because, not like it worked as expected, you would argue. If, on the other hand, you get stuck waiting on it because there's contention, some other thread is holding that lock, then you may want to include it, right? So we filter based on, you can filter based on both the event type or its name, depending on how you want to look at it, but also on the duration. So for example, then, if it takes longer than 20 milliseconds to grab a lock, then included the information. We also have something called throttling, where we sort of sample events, right? Theoretically, we would generate to include millions of events per second, but you can throttle it to say, well, I'm only interested in one event per second. So that brings down the amount of data. So there are all kinds of ways of filtering it. There's also very powerful configuration, or the ways you can configure JFR that's also very flexible. You can do that both on the command line, through files, or online using the APIs that we expose. So that goes for every event, its duration, sort of the threshold at which to include it or not. You can configure the size of the recording, both in memory and on disk. There's file rotation built in, so if you want to keep the 7 last recordings but sort of continuously rotate them, that's also supported. And I mentioned that stack traces can be expensive. That's the one sort of thing that can affect performance quite a lot. So you can control the stack depth, how many stack frames you want to include. By default, I think it's 64, something like that, maybe 32. And depending on your application, that may be sufficient or it may be too little, right? But that's one thing that does affect performance a bit. So again, by default, we're making sure that the overhead is really low, less than 1%, but you can include more information and then the overhead may be higher. I'll also say for completeness that we are working on improving stack trace grabbing, sort of the code, the functionality that gets the stack trace significantly, and that's going to be sped up quite significantly over the next few, I shouldn't promise releases, but at least years, let's say. So it's work in progress. I mentioned that there are ways of controlling Flight Recorder and how you use it. One of the obvious ways is to say when you start up your application that I want to enable JDK Flight Recorder. And I encourage you to do this, right? Again, the overhead is low and the information will be there when you need it. And you do that using the Start Flight Recording option, command line option, -XX Start Flight Recording. That option takes a bunch of sub-options or commands. So we'll look at a bit more in depth what that will look like later. But don't fret, if you forget to do this on the command line at startup, there are also ways of doing it while the application is running later. There's something we call settings files or configuration files. And those are sort of describing all the whole JFR configuration. There are 2 built into the JDK itself. It's the default configuration called default.jfc. So if you go into your JDK, you'll find in one of the directories a file called default.jfc. And it has information about all the events that should be enabled and some of the settings related to those events. There's another settings file called profile, and as you can imagine, that's more for getting additional profiling information. And you can create your own configuration files. If there are, instead of lining up, hundreds or whatever, or like several lines worth of command line at startup, you can instead encode that all in a configuration file and then point to that file instead. So just for information. Tip of the day is, even though we do have these 2 files included in the JDK, don't go modify them. Chances are that will surprise somebody later, and that somebody may be you. So instead, make a copy. And if you want to create a file from scratch, we have a very helpful tool called JFR, which you'll find in your Java Home bin directory. And that command has an option, a subcommand called configure. And with that, you can actually do sort of interactive creation on one of these configuration files. So yeah, in case you want to play around with that. Okay, so I've said that JFR is super performant and efficient and all of that. So why is that? Well, I alluded to it earlier. A lot of the information that we include and capture as part of JFR is actually stuff that we already collect. So take JIT compilation, for example. The whole process of driving what gets compiled and how we compile it is something that the JVM already has. So the realization 25 years ago is that, well, we already have the information, so if we can just encode it efficiently and spit it out of the JVM, then that's all of a sudden valuable to sustaining a support, right? So that's part of it. We're already collecting this. The other reason is that we have really optimized the path from the application or from the application threads in how they produce this data. And so in particular, when a thread produces an event, it's all thread local. there's no synchronization really happening. It's all writing things to thread local buffers. And then in the background in the JVM, other threads will take over and package that stuff up and potentially dump it to disk, right? So on the critical path in the application, there is sort of nothing, right? There are a few striding writes, and those normally hit the cache nicely. So that's part of the reason why it's efficient. This data is then aggregated into recordings and stored to disk, as I said. It's worth knowing that even the on-file or on-disk file format is very compact. It's not, expanded JSON with lots of strings in it, quite the opposite. It's like binary formatted. We're making use of the fact that lots of integers have, are 0 or, they're not filling the 64 bits or whatever it could be. It's like there's a very, very dense and optimized format. And that means that we can, produce that data very quickly, and you can also send it around to your colleagues for analysis offline and without the enormous overhead that maybe would come with it otherwise. And another good thing to know is that the JDK Flight recordings are self-describing. So there's no need to carry data about what events are, what they look like, and all of that. All of that exists in the recording itself. So what the event names are, the fields they have, even some annotation data, and I'll show you a bit what that looks like later, so that you can see that, okay, I see that this event is called garbage collection, but what does it mean, right? So we have metadata that explains that, this is information about a garbage collection, that blah, 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 that sort of thing. Okay, so that's enough theory, and now I'm gonna go into demo mode, and let's see how that works out. Wish me luck. So let's get started to start with, so I have here your canonical Hello World application. I guess it hasn't been updated for JDK 26. I should drop the public static and all of that, but it's a Hello World, let's say. So I talked about the fact that you can start flight recording, and we're going to say dump that information. When you do this recording, dump it to a file called hello.jfr, and then I run it. And as you can see, you got some debugging information from JFR saying I started recording, and you didn't tell me otherwise, so I'm going to use a max file size of 250 megabytes as the default. And here's how you can interact with it, sort of. But since Hello World terminates very quickly, what we'll see is, hello.jfr. Okay, so what is hello.jfr? As I mentioned, we have a command line tool. You'll find this in your Java home bin directory, and it's called JFR. And it has a bunch of sub-commands. You can either run JFR or you can run JFR help, and you'll get some information about the sub-commands that are included. One of them, for example, is summary. So let's have a look at what that does. So this is just giving you a sort of a high-level summary of what this recording file is. So it's telling you that it's version 2.1. This is of the flight recording file itself, not the JDK. It says one chunk. I'm not going to go into chunks as much, but like in order to get the data, to be able to produce the data and reason about it and shuffle it around and all of that, we divide data into chunks. And it has some other information, including also the events. Which events got included and how many of them are there, that sort of thing. Okay. Another thing you can do is to just print the events. So let's do that. And here you'll get just the raw list of events. So the first one is called JDK Active Recording. So it's the information about the JFR recording itself. I can scroll through this. There are, thousands of events like this, right? Different kinds. I'll go through more sort of in detail what the events look like a bit later. You can also ask for JSON if you like JSON. Or you can ask, there sure are a lot of events in this recording. Can I please just get the garbage? Oh, actually, that's a bad one. JVM information. Events. Actually, let's drop JSON. So here is just the events that are of the kind jdk.jvm information. And you'll see things like the command line and which JVM version was being used and all of that. So this is obviously very raw sort of level of interacting with JFR. You'll get the recording, you can dump out the events. I'll show you the level above that in a second. But before I do that, I also mentioned that what happens if you start running your beloved Hello World or application in general, and you forget to start it with Flight Recorder. So I'm going to start here in the background, hello loop, which, does pretty much what you expect it to. I guess it's sort of just an application running in a loop. I need something to interact with. How many people have seen or used JCMD? Okay, a few of you. It also lives in your Java home bin directory. And in the past, we had all kinds of JStack and JInfo and JMap and J whatever. More and more, we're centering everything on the JCMD command. So what JCMD is a way of interacting with your Java processes. And in this case, if you just run JCMD, it will do its best listing the current Java processes that are running on the machine. You see that I actually have a hello loop running from before. So let's see which one we interact with now. But in either case, you see the other ones as well. If you give it a PID, you'll get the commands that target JVM supports. So for example, here I can say vm.info. And it will connect to the running VM, and it will ask it to produce this data and send it back and then print it out, right? But if we scroll back a bit here, we'll see that there are a bunch of JFR-related commands as well. So that's what I'm going to focus on for this presentation, at least. There is, among other things, jfr.start. So let's have a look at what jfr.start does. So if I just run that, it will start recording, much like if I had done that on command line, but on a running process. Right? So this is what makes it possible to do this even if the process is already running. And we can also check, jfr.check will list the currently running recordings. So there's currently only one, which is expected, I guess. We can dump to hello loop. And now we've written down that recording, right? So instead of waiting for the application to exit, we've asked it to produce whatever event data it's collected to a file. So if we look at that, we now have a hello loop. And it contains more or less the same things, right? What you'd expect. And then finally, we can stop it. So if I do stop name, it's now stopped the recordings. And if I go back and run check again, you'll see that no recordings are running anymore. So that hopefully gives you a feeling for how you can sort of interact with JFR, right? I can certainly do that. Only for you, Dan. Better? Sweet. Okay, any questions on that? Next up is here's how we can use JFR on the sort of the higher level. And I'm on thin ice. Yes?
What's the name that you could have 4 recorders in one run?
Yes, exactly. So exactly that. So for every recording you start, there will be a new name, right? This is like a running number. But exactly, multiple recordings can be running at any given point. It should be noted that there's only one set of data being collected. So if you have multiple recordings with different configurations, the union will be collected in the recording. It's too costly for us to sort of separate it out into different sets of configuration options or limit things that way. So that's worth knowing, I guess.
One advice I got is specify a duration at least 20 minutes. Is that a good number, or is that just...
That all depends obviously on your application, right? So I know that even at Oracle, it all depends on which service team you're in. What you feel is comfortable, because effectively it's like when things go wrong, you want to have enough data, historical data. Maybe this is a good time to mention that, right? This is, after all, capturing now data in such a way that when something goes wrong, or if something goes wrong, hopefully, you can then snapshot it and go back in time. But obviously, if you've thrown away the old information, then you won't have enough of it, right? So it very much varies depending on your application and the amount of data that you're willing to keep either in memory or on disk.
Does this profiling suffer from the save by bias problem?
It did, but we've fixed that. So we have something that we call cooperative sampling that went into JDK 25, I want to say, and we're sort of addressing the save point bias issue. So that is no longer there. And for those of you who don't know, in order to walk the stack in the JVM, we need to stop it at a point where we have enough information to start that stack walk, and we call those points save points. And the challenge then is obviously that if you only get thread samples from save points, then you may not actually get accurate information, representative information, because you're now only really getting information at the save points. But we actually changed that. So now when we stop the thread, if it's not at a safe point, we grab just enough information and we let it continue. And then we sort of reconstruct whatever the state was and walk the stack from there. No, not. Of course, there's a small overhead, right? But not that we've ever worried about. Let's say it's very efficient. Yeah, so there's an in-memory. The way it works is in the background there's an in-memory buffer, sort of, and then when that fills up, we dump it down to disk, or like 1 second we dump it down, sort of. So that's background stuff. Yes.
So does that mean you're between?
Yeah, so that's maybe a good thing to comment on as well. So flight recordings or the event data is all sort of asynchronous. It's not like we act on the events being recorded or produced, right? They're all being pushed into this thread local buffer and then handled in the background as sort of rolled up. Oh, the stack trace. From every perspective, it's synchronous. You will not know that we did this magic in the background of reconstructing it. So it's basically, we stop wherever that thread was executing, we'll actually grab the right information, the accurate sample information.
We got through two configurations, the default and the profile. Default is to say 1% overhead. What's the profile? It's bigger?
It's bigger because it does include more information. It's still not horrible, right? It's not like this is going to get your application, like bring it down to your knees, right? But it's like with the default configuration, we're really trying to uphold that less than 1% guarantee. It's a soft guarantee, to be clear, but that said, right? Then profiling will include more information, so there is more overhead. But I'd say don't be afraid to try it, right? It's I'm gonna guess that it's still very reasonable.
Want to put a number, 2%, 5%?
I don't know. Try it out and let me know, and I'll incorporate that for my next presentation. Yes. That's a good question. I don't know that we have a specific answer to that, but certainly we're in general sort of trying to make sure that we avoid bias, because obviously it's costly if you get information and you can't trust it in the end. We think that we do a very good job of it, and frankly, a lot of the information, even for, as you said, right, the bias towards large objects or all that, it's from many perspectives, it's still, at least from what we're seeing, right, and how people are using this, it's still arguably good enough, right? And there's always this trade-off between accuracy and performance, and so we need to weigh that and balance it a bit as well.
Quite a lot of
Oh, okay. Would be happy to.
Quick follow-up. So the stack traces, does that work fully properly with virtual threads? And do you know what the performance contrast is between the use of async get call trace?
So starting with Loom or virtual threads, yes, JFR does work with virtual threads. We made sure that was designed into virtual threads and got implemented along with it.
For stack traces?
For stack traces as well, yes. And async get call trace. Sorry, can you clarify the question around async get call trace?
I'm just curious how the performance for getting the stack trace in JFR compares to if you're just using async get call trace directly.
Yes. So for those of you who don't know, there is a very unsupported and internal, let's call it, API called the async get call trace. So it's a C function that Hotspot sort of implements and that a lot of profiling tools use to get information out of the VM. I'm going to say that JFR's stack trace collection will always be faster than what async get call trace can do, especially if you want to do it safely as well, which is one of the key things I'm going to say that async get call trace maybe doesn't do. Like, it's if you use that API, you're on your own because it may do things to the VM that you don't like. But we're slowly sort of implementing replacement logic for that and thinking through what that will look like in the future. Okay, I'll move on with the other half of the demo, sort of. So this is something I've never done before, so I hope it works out. This is a series of fake but hopefully powerful examples of what JFR could be used like for the real world, right? So my colleague, my team member Eric Galin prepared these for me. So basically the way this works is, imagine that you have a support team and they're sending you, or an application team, some team deploying something, or a customer, and they send you a JFR recording and they say that something is wrong, help me, right? So in this first case, what they're saying is, The application is slow and I have no idea why. Help us, right? Okay, so they've sent us a few requests per minute to JFR. So let's have a look at what that does, right, and what it is. And what I'm going to demo now is, as I mentioned, the print functionality that we saw earlier just like prints out the events themselves. And that can be powerful, but it's also sort of very raw, right? It's very low level. So I'm going to demo a series of views. And views here are effectively taking those events, the event data, and it's aggregating them and displaying it in some higher level form that hopefully makes more sense to consume for us, right? So the first thing I'll do is say, okay, so they say it's slow. Let's have a look at what the CPU load looks like for that machine or the JVM. And you see here a series of different metrics. Let's focus on the ones at the bottom for now. It says machine total, minimum, average, and maximum. And they're all pretty high, right? So like this is a machine that is heavily utilized. So for whatever reason, it's using a lot of CPU. And that may be your issue, right? Okay, so why is it doing that? Well, another view that we have is called hot methods. And if I run that, you'll see that it spits out a list, an ordered list, a sorted list of the hottest methods. Where is execution happening a lot, right? And so in this case, we see that the SpecJDK delivery transaction pre-process method is consuming something in the order of 30% of the CPU. Okay, so this would be a good place to start, right? Your application is busy doing something, and here seems to be one of the key places. It wouldn't surprise me, for example, if getNode and successor here are close relatives to that, right? But that's just an example, right? So it's getting you closer to understanding why is it consuming all this CPU. Okay, so that was a high-level example. Let's have a look at the next one. So here we have a latency critical business application. It's really important that this is up and running and is responding really quickly. So, think millisecond pause times is bad. Okay, we do the same general thing. We say JFR view, CPU load, some slow requests. So some of them are taking time for whatever reason is what we're hearing from our support team. Here you're now seeing the same general numbers that we looked at earlier, the CPU time, but they're not that bad, right? It's like this CPU is not under duress, under all that much stress. So this doesn't necessarily seem to be the problem. So what if we do GC pauses instead? Just, looking at what's the GC up to? And here we do see, looking at, again, you'll see in a lot of different kinds of metrics, but focusing at the bottom ones there, you see the P99 and the P99.9, and the max pause time is 206 milliseconds. So if our goal here is to make sure that that application is up and running with single-digit millisecond pause times, this is a problem. Okay, so why would that be? Well, one of the things we can do is to say, show me the JVM information. And here you'll see, as I showed you earlier, I showed you the event. Here's the view of that. So it's saying, well, we're running these and those versions. I apologize for this being JDK 25. Should be 26, of course. But we're seeing, among other things here, that somebody has decided to use serial GC, right? This is obviously a sort of a synthetic example, but, take it for what it is. This could be something else. But in this case, yeah, that could be the reason, right? So serial, as you may know, is not really, like its goal is not to have good pause times. Its goal is to run on small machines and, do that sort of efficiently, right? So maybe that's the problem. So what we tried in this hypothetical world is to run with ZGC, which is one of our new garbage collectors. And if I do GC pauses and I say, so now we asked the team to do that and they sent us back a JDK flight recording of the new deployment running with ZGC. And I run the same command to showcase or show you the GC pause times. You now see that the pause times are, well, sort of microseconds, right? So it's much better, much better. And as a matter of fact, one of the other things we can do is look at, there's a view called just GC. And then if I don't scroll up quite as much, you'll see the individual collections and the pause times for that, right? So again, hypothetical example, of course, but this is giving you sort of an indication of what JFR can be used for. Okay, up next, let's look at memory leaks. This is a slightly more complicated example, so hang in there. What I'll do here is, let's see, what will I do here? I need to cheat. Sorry. Oh yeah. So right. So the team is saying we're running out of memory. Right. Something is eating up all the heap space, and we'd like to know why. And what we've done then is to ask the team to run with a special subcommand to JFR, which is called path to GC roots equals true. So you can, like, I'm not going to go into the details, but more or less what that does is capture more of the information about how objects refer to each other on the heap, right? So that we can reason about them in a more powerful way. And they did that, and they sent us the memory leak.jfr file. And the thing you should know about this is, hold on. Wish I would have memorized this bit, but yes, view recording is what I'm looking for. Recording memory leak. The thing you should know about memory leaks is JFR is keeping track of all these objects or samples, information about how objects are being, the liveness, right? How long they live. And obviously, if objects were allocated just before this recording was dumped, they haven't leaked yet, right? Like they were just allocated. Chances are the next garbage collection would come along and remove them because they're no longer referenced. And on the other hand, if the objects were allocated at the very start of the Java application, chances are that that's also not a leak, right? It was something during startup and that's supposed to be there. So the leaks we're looking for is more in the span from a few minutes after the application started to the last few minutes leading up to this recording. So one of the first things we do is to figure out how long was this recording? How long has the application been up and running? In this case, that's just over 20 minutes. So then what we'll do is we'll go look for events, JDK old object sample. Is that right? But in the memory leak file. Okay, and then I'll search for something called object age. And I'll just go down a bit, right? So we're looking for something that has lived for more than 5 minutes, but less than 15, sort of. And so let's pick this one, right? Random object. Here you'll see that this object has lived for 9 minutes, so it's a candidate for leak. Maybe this is what's leaking. And one of the things we'll get here is, it's not a stack trace, it's the chain of references on the Java heap, right? So you will see from the top down here that we have a Java string, which has a byte array. Java strings are either byte arrays or carry arrays in the background, right? Which is being referenced from something called logging work, which lives in a hash map. And for those of you who know how hash maps are implemented, there's an array in the background. And here's a warning bell. So in the hash map here, we have a node array, and that array has 2 million entries in it. And that's a very large hash map for anybody who's used hash maps. It could be the right thing, right? But I happen to know that that's not how this application is supposed to work, right? So smoking gun, something is weird here. And now we know that it's inside of the login class. And if we go down, we'll also see the corresponding stack trace. So now we know to go look in the login class for like the memory leak, and it's on line 33 in this case. So I'm not going to talk through this. It's a sort of a silly example, right? But the way this happens to work is that there's some kind of login. There's a service which does a login in the background, and it keeps track of current logins. And one of the things it has then is a login work instance or a class or a type. And that's what we saw was leaking or was being referred to, right? It has an ID and a username. And it turns out that what it does is it adds to this hash map a new login work, and then it expects when it's done to remove that same thing, but it does that by creating a new instance of login work. And that would be fine as long as login work had implemented hash code and equals, right? But it hasn't. So obviously this will do nothing. It will just create a new instance and not be able to remove it. Yes.
Question. So say we had a God class that had more than one hash map, right? Like there's a dozen there. Does it go at the level of like, hey, it's this object ID that allows us to...
It sort of tries to backtrack, right? So figure out how that thing is being referenced in the end. Does that answer the question?
So I guess this one is, it's obvious that we have one hash map on the class, but if there's like, what if there's 10 or there's 15?
Yeah, fair enough. I see what you're saying. So we can't, obviously there's no line number to refer to, right? But hopefully from the stack trace, you'll still be able to see that like that line references that specific hash map, maybe. Okay. I'll say for completeness that another way of working around this, instead of implementing hash code and equals, is to just use the same object. And finally, yet another way of doing it is to create a record of this small class here instead. With a record, you'll already get hash code and equals on the fly, right? So, you know, again, maybe silly, but like that's you have to obviously imagine that this is your application on a high level. And then finally, we now have again our support team telling us that. Or actually maybe it's the deployment team, the DevOps team. They're screaming at us because the application is not up and running. We need help. It's not at all responding, right? It's not doing the right thing. Okay, and they sent us a J4 recording. It's called No Response. So just on a hunch, so you'll have to trust me on this, I'm going to say, let's have a look at what exceptions are being thrown in this application. And we see here that the one at the very top, the one that is being thrown the most, is Java SQL exception. That's fishy. We shouldn't be throwing exceptions of the SQL kind. Okay, so why is that happening? Well, we have another view called exception by message. And if we run that instead, you'll get the same general thing, but instead the message of the exception, and you'll see that no suitable driver found for blah. So obviously here we're failing to find the driver to connect to the database to start with, right? Now, again, work with me. These are all artificial examples, but hopefully it gives you a feeling for the kind of information that is in JFR, and also that you can look at the raw events, but with the view like the tool here and the views, you can actually get something that is maybe more easily digestible for human beings. As a final thing, I'll just run a health report. But I'll do that here. Okay, now. Okay, so this is just another example of what we did with JFR. I'll make the window ever so slightly bigger. So this is a Java agent. And I'm not going to go into what a Java agent is, but basically it's like this is a top-like thing running for your Java application, right? So it's showing information about garbage collection, CPU time, and all of that. It's showing the top allocating methods, and it's showing the hot methods that are running, all in sort of a compact view, right? And it's continuously updating this for your application. So the health, I think I have a link to it on the last page of the presentation. It's a demo that you can go have a look at. And again, hopefully all of these things at least give you a feeling for what JFR is and how it can be used. I know that it can be hard just looking at slides, getting a feeling for that. So, hey, the demo sort of worked. That's nice. Okay, so we already did talk about using JFR. There's the command line. If you want to include JFR from the very start, there's also JCMD to do that on a running VM. There's also a JMX interface. So there's a Flight Recorder MX Bean. So if you manage to get hold of a JMX connection, you can actually do this remotely as well. Start recordings, get the data, analyze it, and I'll show you a bit more of what that looks like. Here are some of the methods that are exposed through that bean. So yeah, very powerful mechanisms for controlling recordings, be it locally or remotely. There's also a graphical user interface that I alluded to earlier. It's called Mission Control. And it has, like, all of the stuff that I did on the command line here, or more or less at least all of the stuff I did on the command line, can be looked at in Mission Control as well. It has some other views, if you so will, and it has some, it's not like for like, but that said, it provides a more graphical and maybe user-friendly way of looking at the same general data. So it may be worth knowing that as well. How much time do I have? I'll go through this very quickly. So I talked about analyzing data, and I think it's probably good to know that this can be done in many different ways. So you can obviously do the command line tool that we just looked at. There are also APIs for doing this. We refer to them as event streaming APIs. And I showcase here two different ways of doing that. At the top, you see using the recording stream inside of the same process, right? So you're starting up your application and you want to, for some reason, do the JFR processing in the same process as your Java application. So in this case, we ask for a configuration, we start a recording, or we create a recording stream, and we say that if there's an event called JDK.garbage collection, do this. And this happens to be a method reference that just prints that event to standard out. But it could be anything, right? You could act on the event and decide to enable other events or dump the recording or whatever you want to do. And then start is what actually starts this thread processing that. Very similarly, you can do that out of process. So on the same machine through the file system, you just create an event stream using the open repository method. There's a missing parenthesis, darn. And the same thing goes, small lambda there to do whatever you feel like. And then finally, over JMX, the API, once you get hold of your JMX connection, is very similar. So the first stuff is getting the JMX connection, and then hopefully the shape of the code looks very similar and familiar, right? So it's called a remote recording stream, and you do the same thing. So there are a couple of links down there. I have them on the last page as well. And I think I'll skip this one, and I skipped this one. So JFR, I'll say hopefully one sort of final time, use it in production, right? That's why we designed it the way we did. It's very powerful if you use it in production. And as a matter of fact, we try to make sure that JFR can be used at scale, right? Not just for a single JVM that you're monitoring, but for a whole fleet of JVMs, your huge deployments, tens of thousands of JFR or JVMs running with JFR enabled. And again, the overhead per instance is very low. You can optionally dump the data, right? So that's the nice part. Have it on in the background, but only if something goes wrong. Only if you see that latency spike or some error is triggered. Only then will you actually dump the recording, right? And then you get the historical. You can go back in time, right? It's a time machine that allows you to go back and see what led up to that. And what else happened at the same time. So for example, I know that my query took a long time. Is that because a garbage collection happened at the same time, or was it the connection to the database or something like that? We have something called Java Management Service. It's an Oracle product that in OCI native service that monitors large fleets of JVMs, and JFR is a key part of that as well. So it's already doing a lot of this, coordinating things, allows you to turn on and control recordings on a huge fleet of JVMs. You can have a look at it at oracle.com/java/JMS. And in summary, JFR is an event recording framework. So hopefully through both the slides and the demos, you've gotten a feeling for what that means. We like to think that it's a very powerful and flexible system, and provides a lot of tuning knobs and configuration options for really getting the data that you need, both produced and consumed and analyzed later. And it has extremely low overhead, so use it in production. Darn, I said it one last time. Okay, so here are a bunch of resources, and I'll open for questions.
You said that they have to JFR the production and then only dump when something goes wrong, like latency increase or something, right? Is that something you have to handle through the profile configuration or?
No, you're right. So it all depends on the kind of information you want to include. But what I will say about the default recording or the default configuration is that it already includes a lot of stuff, the stuff that we feel is like critical for analysis, I'm going to say, while having low enough overhead to be on in production, right? But of course, depending on your exact problem, you may want to turn on additional information. I mentioned stack traces are limited, for example. So maybe you want to have deeper stack traces if your application is such that there are, we've seen this in the field, right? Thousands of stack frames, and only there at the bottom will you actually see what is actually causing the problem. So it depends a bit, but the default configuration is a good one to start with.
So if we enable like the size of the file is going to be too large, like a heap dump, or it's going to be?
Yeah, so it's heap dumps can be really large, right? Both because, well, they're dumping the whole heap, but also because they're not very efficiently encoded. They're not very compact. JFR recordings are, I'm going to say, very small, considering all the data and the details that are in there. So take stack traces, right? The naive way of including that in the recording would be as strings, right? For every event, you include the strings for every frame. That's very much not how we do things, right? So instead, we have per frame just an ID that refers to a string pool or a stack frame string pool, if you so will. So the event itself is very small, and then the metadata is ever so slightly bigger, right? But then that can be reused for every event. So you'll find that the recordings are very, very small, again, given the data that they do encode.
Okay. So like GC log, right? We can dump on out of memory exception happens, like something like that for JFR. Is there any setting that we can enable?
Yes, so you could, for example, do that using the remote or the event streaming that I talked about, right? So take this code, right? So here I subscribe to JDK.garbage collection. That could be, some other condition, right? And the system out print line could be dump the recording to disk, right? So it's very flexible in, how you act on commands on events.
Let's say in production, does JFR allow you to estimate how much performance hit, how much performance you lose? Running it in production with different, let's say this profile equal to profile, and does have that kind of information. So you not compare the application with JFR on or off, but
Right.
you do this real time.
Yeah, exactly. So it's obviously hard for JFR to know what, like, performance in the end is what your application, your deployment requires, right? That's something only you can decide in the end. What we've done with the default recording configuration is to measure across a large number of applications to make sure that in all the cases we can see, right, it's low overhead. But there's no built-in mechanism to sort of show the performance overhead, if I put it that way. I'm being asked to wrap up, but I'll be here or out in the hallway and take further questions if you have them. So thank you very much for coming.